Hi, my name is Gina, and my partner's name is Jason, and today we will be discussing eicosanoids and their role in inflammation. So, to start off our discussion, we're going to talk about what exactly are eicosanoids. Eicosanoids are derived from the oxidation of omega-3 or omega-6 fatty acids, and primarily arachidonic acid, which is an omega-6 fatty acid. They're involved in signaling growth and inflammation. And in general, omega-6 fatty acids are primarily involved in the inflammatory response. Eicosanoids can fall into one of several families. Prostanoids, which include thromboxanes, prostacyclins, and prostaglandins, leukotrienes, and lipoxins and eoxins. For each of these families, there are three different series. Series 1 and 3 are thought to be good eicosanoids, while Series 2 can be potentially harmful. Series 1 eicosanoids are responsible for reducing inflammation, dilating blood vessels, and inhibiting blood clotting. These attributes help the body to heal and continue blood flow to certain areas of the body. Series 2 eicosanoids increase inflammation, constrict blood flow, and encourage blood clotting. They are used in response to an injury, but if levels of Series 2 eicosanoids are too high, they can be potentially harmful and could result in arthritis, diabetic nerve damage, high blood pressure, allergies, skin inflammations, and even cancer. Series 3 eicosanoids can be responsible for either dilating or restricting blood vessels, weakly increasing inflammation, and weakly inhibiting blood clotting. Because these different series have opposing effects, it's important to keep them in balance. So now we know what eicosanoids are, but how are they made and how are they synthesized? So eicosanoids are derived from mainly arachidonic acid, which is what I mentioned before, which is a carbon-20 fatty acid, dihomogamma-linoleic acid, also known as DGLA, or eicosapentaenoic acid, linoleic acid, which is ingested as a gamma-linoleic acid, can be found in different seed oils and is converted to arachidonic acid, which is then stored on the C2 position of membrane phospholipids. Arachidonic acid is then released upon activation of phospholipase A2 after being stimulated by either trauma, cytokines, growth factors, or any other stimulation. All mammalian cells, with the exception of erythrocytes, have the ability to synthesize eicosanoids. There are two main pathways for synthesizing eicosanoids: the cyclic pathway, which synthesizes prostaglandins and thromboxanes, and the linear pathway, which synthesizes leukotrienes. During the cyclic pathway, prostaglandin G/H synthase has two activities, one of which involves cyclooxygenase, which can be either in the COX-1 or COX-2 forms, or peroxidase. COX-1 is primarily found in gastric mucosa, kidneys, platelets, and vascular endothelial cells. COX-2 is generally found in macrophages and monocytes and is typically expressed in response to platelet activating factor, or interleukin-1. Both COX-1 and COX-2 can convert arachidonic acid to PGG2 and then to PGH2. PGH2 is then converted to prostaglandins, prostacyclin, or thromboxane by tissue-specific isomers. COX-2 can also convert arachidonic acid to 15-HETEs, which is then further metabolized into lipoxins. In the linear pathway, arachidonic acid is converted with use of arachidonate lipoxygenases, or also called LOXes, which is far easier to say. These can be found in three different forms: 5-LOX, 12-LOX, and 15-LOX. 5-LOX gives rise to leukotrienes, which are then synthesized in white blood cells, mast cells, the lungs, spleen, brain, and heart. 12 and 15-LOX give rise to lipoxins and platelets and epithelial cells, respectively. So that was eicosanoids in a nutshell. I hope you enjoyed it, and now I will pass it over to Jason to talk more about inflammation.